Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you're doing good. In this, we're going to see problem design task manager. Now, the problem 3 is already live. You can just go and watch it on the channel. This is a very simple, straightforward problem, a bit lengthy code. That's it. It simply says that you are given some tasks and that is what you have to manage. The tasks are given as a vector of int, which means that each individual task is built up of user ID, task ID, and priority. Now, although you can easily handle, again, you can imagine it as a list of list or a vector of vector. You can easily handle this as a vector itself, but usually in an interview, it's a very important practice to make it as a class. And class will have the corresponding attributes as user ID, task ID, and priority. Make sure it is very important. Gone are the days where you are simply using v0, v1, v2. Gone. Again, like v bracket 0 to actually address that specific attribute. It is a very bad practice. Make sure you make some kind of data, like I have written as a task data. Name it as anything. It will have 3 attributes: user ID, task ID, and priority, addressed by its objects. Right? Make sure you do this. Now, okay, this we will handle it in constructor. Let's see what else you have to do. We have to add. Okay, let's say the person gives us some specific user ID, task ID, priority. I'll just add that specific task. This 3 trio will make one task. What is the operation number 2? Operation is to edit. You have to edit a task. I will be given a task ID, and edit means editing with the new priority, which means you will be given, or you should map your task ID with the priority. So technically it makes sense that for task ID I should keep a priority, so that it is easy for me to find for a specific task ID what is the current priority and simply update that ASAP. So to keep track of the priority, I can simply make a hash map from the task ID to the priority itself. That's one way. Or I can make a hash map from task ID to the task data, because task data internally stores everything. Now we will see, okay, what we can use, but okay, this is the 2 possible options I have right now. Next operation is remove. It says that given a task ID, simply remove it, which means I need to have a hash map which will maintain for specific task ID what is the task data entirely, because I have to remove the entire task data altogether. Okay, which means it makes sure that, okay, I will maintain the task data. That is much more beneficial for me. Last operation is exec top. It says that executes the task with the highest priority across all users. So as you can see, we have multiple users and the multiple task ID, multiple priority. So I have to maintain data structure which will have the corresponding tasks, but at the same hand, that tasks are sorted on the basis of priority in that data structure, with the highest priority task at the very top. What is that data structure which gives us the maximum value thing in a very less time? It is either a set or a priority queue. So I'll use a simple max heap, which is a simple priority queue. I'll make sure that my priority queue is of task data, which is sorted, or I should say max heap, that such that the maximum or the highest priority queue is at the very top. For the 2 same priority, they are giving that sorted by the basis of higher task ID. And what if 2 task IDs are same? They cannot be. Okay, and ultimately get this done, which means when I say get this done, which means after executing that corresponding task, the task ID is removed. It will be removed, same as this operation. Wait, is gone. Yeah, this operation. And also we have to return the corresponding user ID. Okay, you got to realize that you will use a priority queue for this operation. You will need to use a hash map for operation remove and edit. And for adding, I'll simply add, again, I know that I have to transform this list of list or a vector of vector to a corresponding class structure. So I'll use a corresponding another list of task data where I will copy the corresponding data from the vector of vector to the new list of task data. Or I should say vector of task data. I will copy the data here, and that I will do it in my task manager, or I can do it in addition also, because addition will make sure, okay, some entries are being added or coming in. So that's the ultimately game. That's it. I know the data structure, I know the operation, I know what I have to do. Just simply do it. Let's see the code. So firstly, I'll make another class called as task data. It will have a user ID, task ID, priority. Again, I have not kept encapsulation picture. I'm not using private, static, all that stuff. If you want, you can use it. But here I'll simply initialize it, and also I will say, okay, removed is false. Now, why it is required? That is the primary catch here. We will see a quick, just in a few minutes. As you saw that I will maintain a corresponding priority queue of my tasks. So that's a simple task queue and a tasks hash map, right? Then in my constructor, I know I have to initialize my priority queue, because again, these are not initialized. I have to initialize my priority queue, but I have to also make sure the priority queue should be, if I have two elements, if the priorities are not same, then make sure to sort on the basis of priority with the one having the higher priority on the top. Else, if they are same, then one having the higher task ID on the top. That is my sorting for the priority queue. Initialize my hash map with the empty hash map, and then make sure that for the current tasks in the very beginning, add all those tasks inside my this specific hash map and this specific priority queue. So I simply call the add operation, in which I am just calling these three values. How the add operation look like? Add operation will simply make the task data object for me called as data by saying new task data, give the user ID, task ID and priority, got the corresponding object, simply put that object in my priority queue and update my hash map. I'll update my hash map by saying task map dot put for the given task ID, maintain the object. Same way in the priority queue, just add that data. That's it. Okay. Now, edit operation, simple. For the task ID, get me the corresponding object or get me the corresponding task data. Simply update its corresponding priority with the new priority. So, I'll firstly get the old data which is already there. Again, if the old data is not there already, again, because in an interview there can be multiple edge cases. What if I call for a specific function? You have to handle those exceptions. So if it is not null, which means the data is already there, old data is there, then make sure to put the removed as true. Okay, this is removed now. Now, if it is removed, then what? Make sure that you put up the corresponding new data. Now, you might say, Aryan, I have removed it. I am putting up in my priority queue, but why I am not removing this from my priority queue? That is the biggest operation, which means that as you are editing it, which means obviously you have to find that specific object inside your priority queue. But considering the priority queue is sorted on the basis of what? On the basis of maximum priority queue, sorry, maximum priority, and if the priority is same, then the maximum task ID. Thus, randomly accessing any object or anything in a priority queue is very costly, will take O of n time, where n is the space or the size of the priority queue. Thus, randomly accessing will be very costly. Thus, I cannot randomly access anything in my priority queue. That is the reason I maintained a removed as one more variable, which right now for anything which is removed from the priority queue, I am just marking it. How it is useful, we will see it later on. But I'm just marking it. I'm not removing actually from the priority queue. No, I'm simply marking it. Thus, I will simply make a new data with the new entry of the priority queue and the old entry of the user ID task ID, and then put it in my hash map, put it in my task. Again, when I say put it in my hash map, for the task ID, update it, simply update it, and simply adding the new data in my priority queue. Again, as you can simply see that I haven't removed the old data from the priority queue. It is just that for the old data, I have one variable which tells it is removed or not, that I have simply marked as true. Why it is required? Because we are using a priority queue, and priority queue removal of a random element is very costly. Now, okay, this is done. Same thing, roughly do it for remove also. That for the remove, get the old data, which means the data for, again, hash map will help me to get the corresponding data for a specific task ID. If it is here, which means if it is not null, don't remove from the priority queue. No, don't remove it. Simply mark your data dot removed as true. Okay, it is removed. But again, removing from the hash map is pretty easy. So I can simply use the hash map to simply remove it. Okay, simply remove from the hash map. Now comes the main part, which is execute top, which means get me the top person with the highest priority. If the priority is same, get me the highest task ID. In that case, until the priority queue is empty. Now, Aryan, you can simply check if the priority queue is empty, because if it is empty, then okay, no answer. If it is not empty, then simply get the top value. Why you have written until? Until it is because there are many unnecessary, or I should say, many already removed element in my priority queue right now. So there's a possibility that some element will be removed first, and then I reach to that specific value, which is, oh, it is not removed. Okay, I'll use this now. That is the reason I used a while loop. So as to remove those elements which we marked as true, and thus here I will simply remove it. Again, you saw that only once an element came in, only once it is going away. Thus, I am not wasting any efforts. Again, in the end, I'll tell you one way to not use this remove function. There's another way to use set and hash map. I'll tell you in the end. But here in this, you'll see, okay, while I used a while loop because I know that my top data can be the one which is already removed, which means that top dot removed is true. If it is false, only then come inside. If it is true, which means it is already removed, and you are simply removing it and continuing the corresponding while loop to reach to a specific element which is not removed yet from the priority queue, right? You see, when I say not removed yet, I mean whose flag is removed equal to false. That is not removed yet from the priority queue. We'll simply use that one, which means we'll come inside this loop. We'll simply firstly remove it from the priority queue. After removing it, remove from the hash map. After that, make that top dot removed as true. It is already removed, and then simply return the corresponding user ID. And again, if it is not, then you simply keep on removing the corresponding element from the priority queue. And if you are done, priority becomes empty, return a -1, and thus get your answer done. Now, as I told, with this we use hash map, we use priority queue, and the most important thing is we have to use a removed variable, because of any random access to any random element in a priority queue is very costly. Now, if I say you any random access in priority queue is very costly, can you think of any other data structure which can help us? Obviously, we can use a set here to actually solve our answer. But to maintain for which task ID, what is the corresponding object which I have to maintain a hash map which I'm already maintaining. So in this case, I can use a set also. But again, in general, for highest, all this priority queue is the first instinct for us. That is the reason most intuitive for most of people would be priority queue. Cool. I hope you guys got it. I hope you guys got the entire crux of why this problem is a bit tricky and what makes the problem a bit special. Cool. Bye bye. Take care. If you guys liked it, please smash. Again, I forget asking for likes in the beginning, or sorry, in the mid. But yeah, if you have reached the end, just like it. Bye bye. Take care.